Good evening, everyone. My name is Oleksiy Konashevich. My topic is tokenization of real estate on the blockchain. The cross-blockchain infrastructure, this is something which I consider one of the most important part of my research work during the last 3 years. In a few slides later, I will be talking about it more deeply. So I would like to recap some of my basic ideas that I already presented on board meetings, previous board meetings here. So the idea of the use of the technology that we can digitize our property rights and use electronic systems, especially based on the blockchain technology, to manage our property rights, to automate many legal procedures, and to get rid of lots of bureaucracy, paper especially bureaucracy, and to get rid of many intermediaries. So basically, if we're talking about the rights and legislation, the main idea that now we have in most countries only one way how we protect our property rights. That's the cadastral registries and bodies, state-owned bodies, and they are using some kind of centralized technologies to manage records on property rights. And now we are talking about another alternative technology which is decentralized, and I think it's a good idea to think in the direction that citizens have the right to choose which technologies they want to use to protect their property rights. And basically, it also sticks to the general concept of technological neutrality, which means that technologies and people must decide which technology are better, and we must allow free competition of different technologies. So the idea of the use of the blockchain is based on something which is called tokens. That's a kind of record on the blockchain. So if it's a technology actually concept, but if you put some kind of legal meaning around these kind of record, we can call it a title token, which is an evidence of the ownership of the property right. So we can use smart contracts to automate these relations. We need also something which I decided to call smart laws. What is smart laws? So basically, if we want to have our smart contracts compliant with the law, we need a kind of framework. Now we have a legislative framework which is paper-based, and the idea of smart laws is kind of encoded system which encoded rules which provide some framework for developers that create smart contracts. We also need another layer of governance, and probably these governments must be democratic, and so we do need some kind of electronic voting things. The idea of governance is that we need the mechanism how we introduce smart laws, how we update smart laws, and how we manage them. So that's the general high-level idea. There are some issues which I want to emphasize and discuss here. First one is the issue of permission DLT system, which stands for Permission Distributed Ledger Technology. Sometimes they are called private DLTs, but it's a bit different, but still the same. So the idea is that those systems are centralized. And my rhetorical questions, wow, if we have the blockchain which is decentralized, open, and public, why do we want, or someone wants to have another centralized system instead of that? When different governments and politicians mention that they are going to use kind of permission DLT, or saying that they are going to use permission blockchains, that's a kind of confusing thing, because that's another centralized system. We already have centralized cadastral registries. Another thing which I would like to mention is that if we stick to the idea of decentralized, public, and open system like blockchain is, we have to deal with these things like hard forks. So hard fork is the moment when one system split into two systems, and from this moment, if I had a record in one system, like a token that represents my property right, now we have two systems which split, and I have the same record in two systems which represents my one property rights, which means that it's a kind of logical double spending. I can use both. Another problem is immutability. Well, that's the advantage of the blockchain, because you cannot delete information from the blockchain. It stays there forever. That's the secure way how we store the information. However, the technological concept and the legal concept are not compatible in this sense, because the last 2,000 years since the Roman law, people was thinking in terms of fixing and resolving disputes and legal issues, and so there are some questions like we don't have right now. How do we restore access if the private key is lost? How we proceed inheritance? How we do with litigation, with delegation of rights, and all these things which are not that easy in this kind of environment, blockchain. Because transactions are not retroactive, they are not reversible. Anonymity is another thing we have to deal, because transactions are anonymous, and there are at least two good reasons to think that it's a kind of issue: money laundering and financing terrorism. So basically we need to think about kind of another layer of identification with the blockchain. Another thing which also comes with this technology is personal data and privacy. The thing is that if something goes in the blockchain, it will stay there forever, and no one can delete this information. So I, as a citizen, will be concerned about exposing my personal data. So we also need to think in terms of providing some protocols for keeping privacy. Scalability is another issue and limit of the technology. It's clear that there will be no the blockchain of the blockchain, or the best of the blockchain, basically because we cannot store all transactions in one blockchain. It's not gonna happen ever. So basically we need to think about multiple blockchains. And price volatility is something which comes with the uncensored nature of the technology, because people speculate selling and buying a cryptocurrency, and cryptocurrency is the blood of the system, and to run smart contracts, to run transactions, we need cryptocurrency to pay fees and to pay for the transactions. So that's inevitable thing that we will have in this kind of system. Data insertion on the blockchain is probably one of the fundamental things which comes beyond, or which comes from the cryptocurrency system, because and from the very first block in Bitcoin, Satoshi Nakamoto and team who developed, they inserted some kind of information which wasn't related to the transaction itself. And from that moment, people was thinking, okay, we have this system that securely store information on the blockchain, not only transactions. And so these two important academic papers discusses different methods, different protocols of inserting data, and all other development like smart contracts, tokens, decentralized applications are based on this fundamental thing, that you insert a piece of data, whatever, in the message, the file, or a piece of executing code on the blockchain, and it will be executed or somehow utilized. So here in this slide I will show you some basic understanding of data insertion in creation of tokens, or in other systems it is also called name value storage, which is, you can say, NBS record. So basically here is the block, and we insert some kind of structured information as a kind of entry of the database. This entry has two fields, name and value, or key in value. For example, name, my name is Alex, value is my telephone number. So this part of the protocol catches the information from this part and creates the database on my machine and puts this information to my database. And here this protocol catches the information from other blocks. It's like scanning and hooking information to the database. And finally, if I would like to update my information in the following blocks, I will publish another transaction with the same name Alex and with updated information. I change my telephone number, for example. So the system will do, it will not create another entry but update the database. So basically that's the idea. This part is immutable. We will not be able to change whatever happening there, but by updating the information, we have this dynamic part, which is we are able to change by doing transactions here. This is the basis of the whatever system you will take, the tokens or NVS protocol. And these things, tokens or NVS records, must have some important features. For example, ownership. Because this record is attached to my address, and by having my private key, I control this record or my token. And using my private key, I can sign the transaction and transfer this token from one address to another address. Another thing, lease time. That's the way how I mark this record valid for a period of time. So basically I announced to the system which time I would like to have this record valid, and it also available for all other participants in the system. And I can extend this time, I can reduce this time, I can even delete, which means that I will not be able to delete from this part, but I will be able to control in here by publishing updated information in here. And I can update the value, which I already showed you on the example of telephone number. And what is important here, the name is unique, which is a searchable key in the database, which means that while I own this name, Alex, for example, nobody can publish the same name during this lease time. Now I will be showing you a few slides about digital identity, and after that you will be able to understand why I'm doing this. So basically the idea of the digital identity is based on asymmetric cryptography, and probably this is the most advanced technology for now to manage our digital identities. So it is based on private and public key. And using our private key, we can sign the transaction, and using public key, the publicity people will be able to verify if it was me who signed this transaction. So that's the idea main. But normally we use this technology with so-called public key infrastructure, which is based on certificate authorities or trust service providers in Europe. The idea is that the trust service provider will take your public key, will create a file which is called certificate, standard certificate X509, and will mark this file and will publish this certificate on their server, marking that my identity is valid. If I lost my private key, I will call trust service provider and ask him to mark it as invalid. So basically, if someone uses my private key, everybody will be able to see that it is unauthorized use of my private key. So the idea of inserting data in the blockchain is actually based on the same idea of asymmetric cryptography, because when you publish the transaction on the blockchain, you use exactly the same cryptography with your private key. The only difference here, in this normal situation, you just sign the file. On the blockchain, you sign the transaction and your data which you want to insert in the blockchain. And finally, if we consider the idea of creating digital identity on the blockchain, remember I mentioned this problem, we can use the same exactly cryptography and approach of public key infrastructure. So here is Alice. He created her private key and generated her public key and her address, the cryptocurrency address. And now from this moment, she published, or she created her token, her digital identity, or certificate, whatever you can call, and in name field she will write her name, Alice, or a cryptographic hash or a cryptographic representation of her name. In value she will put the reference. The reference is to the a certificate which Bob created. So Bob will do the same. He will create another token which has name and value, and here is the connection with my record. So if anyone inquires information, if my digital identity is valid, they will be able to trace back to the TSP provider record, which can be either on a centralized server or on the blockchain as well, because that's just a record and the storage where it is being published. If I lost my private key, I ask Bob, who is trust service provider, to mark this record invalid. So from this moment, my digital identity is created and verified. And now from here, I can create smart contracts, tokens, on all these things which we can imagine using this kind of technology. And now we came to the idea of the use these kind of records for cadastral records. Here is the same story. Alice has her private key, her address, blockchain address, and she published and created her token. Name is her cadastral number, and value is information about her land. And now we have still the same story. Here is the Bob. He is the authority. He is the government which authorizes and verifies her right. So, for example, if Alice lives somewhere, I don't know if I can trust this record. If this record is verified by Bob, I can trace back to this record, and because I trust Bob, he is the government, we can trust this record. So here is the basic idea, and we came to a bigger picture of ecosystem of trust. So as I mentioned, we create identity, which is verified by someone, trust service provider. We can create assets which are verified by cadastral bodies, and we can create some sort of records on facts and events on the blockchain. For example, a chamber of commerce in industry in any country will be able to certify, and they're doing is actually certifying some kind of force majeure events and creating this kind of certificates that certify these events. And we can have also notarization of contracts, which is also another way how we can legitimize these kind of things. And now here we came to this protocol, which is cross-blockchain protocol. The idea is that that's the way how we can use multiple blockchains in one bunch or in one bundle. And it also provides a layer of a smart law. So now I will explain you the basic idea. Let's imagine that jurisdiction is a kind of filter. So if we imagine all possible transactions in all registers of the countries, they are either valid or lawful or invalid, unlawful. So the idea of the filter is when we apply these kind of digitized rules, we see only valid or only lawful transactions. And here is that whatever happening here in the field of blockchains, it will goes up because of this filter only in case it is valid and according to the law. So basically here's the idea of this protocol. It will catch information from blocks and will create this kind of layer of the public registry or public database on top of that. And so using these rules in this protocol, they will catch only and if this information is per the law and creates this sort of logic of rules. So here is how I solved the problem of the hard fork. So we have two systems which is split like Ethereum and Ethereum Classic. I had two tokens in both systems. I call it the problem of Schrödinger cat because now it's in a black box. We don't know if it's valid or not. It's not a legal collision. But from the moment I do my first transaction, I do my choice. Which of these blockchains I would like to use in the future. And so from this moment, this protocol will not be following whatever I do in this, because I already have chosen this part of this. So that's the idea of the protocol. Another problem which I mentioned, enforceability or immutability of transactions. So let's imagine Bob has stolen the token from Alice. It can happen. And now Alice went to the police, and then was a procedure, and the court rules that this token does not belong to Bob, and we need to reinstate her reimburse her rights. And now, because we cannot change anything from here, we will have these transactions forever. But because of this filter that we applied, and the court who uses their own authorized address to publish a patch to this filter, which will reinstate her right, we now ignore the fact that Bob unlawfully owns his token, and we recreate a new token for Alice. So that's why we can have our legal system on top of the blockchain system. And now a few slides, I will explain some basic things about privacy by design and distributed identifiers. So this method was introduced by Mikhail Tutin last year, is a developer at EOS Hackathon. So that's, he used Merkle tree and the concept of selective disclosure. Here as leaves we can have our personal data, like my name, my date of birth, address, education, whatever I would like to attach here. And the root, which is just a hash sum, is a cryptographic piece of information. It is signed by trust service provider, and it is published on the blockchain. So this part is not accessible to anyone. It can be stored on private servers, it can be stored even on my own device, and I will be controlling this information. But the only thing which is available is just cryptographic signature and the root of this information. And so here how it works, it's just a simple example. I will come to the alcohol store, the seller will ask me if I am 21 years old, and I will choose only 3 fields: the root, which is signed by trust service provider, my picture, and date of birth, and I will present it to the seller. And because seller is able to check all this information on the blockchain, if this root is signed by trust service provider, he will be able to verify if this information about me. So in this story, I even didn't disclose my name, my address, my social security number, whatever. I just disclosed only information which is needed at this point of time. To manage our digital ID according to European eIDS regulation, and to create qualified signature, we can use secure devices like smart contracts, hardware wallets, and all other things. Here are some basics scheme for decentralized TSP system. Here Alice can have in her own list the list of trust service provider whom she trusts. It can be the government root, the private trust service provider. It can be also a web of trust, because Alice doesn't know Charles, but Bob certified or verified his identity, and because Bob in the list of Alice, she created her own web of trust. Now she can trust Bob as well. There is another scheme. For example, Alice can have only one digital identity. In her value, she will include the list of trust service providers which certified her identity. And it can be also in other countries. So basically, that's the main main convenience of this story. She has only one digital identity which is verified by different providers. And the last scheme, So here is Alice, and she created, it's called derivatives digital identifiers. So her digital identity is verified by trust service provider, and on the secure device she has her private key. She puts this private key in the safe place at home, and she doesn't need to use it every day. But before that, she created a bunch of different derivatives, which can be on the smart card, on the smartphone, kind of alias for shopping or whatever, or even anonymous digital identity. So if someone sees this digital identity, they will not know who is she, but they will know that her identity is verified, identified. But the main advantage of this story, that if she lost, for example, her smartphone, she doesn't need to go to Bob again. She will use her main digital identity to reissue her own certificate and use it again. Oh, that was my last slide. Thank you for your attention.